Good evening friends. I hope you are following the thermodynamic video lectures. Today our goal is to learn about the how the heat engine is working. So in the previous lecture we learned about the essential parts in the heat engine. So it will consisting of high temperature area, that is called as a source. So it is at a high temperature. So it will have the working substance will have the, it is a working substance, it is the low temperature part of the sink. So it is the low temperature part of the sink. There are the three important major parts are there. It is the working substance, So first what we will do means the working substance is connected with the source. Then due to the contacting of the working substance with the source, due to the high temperature of the source, some of the heat energy will be absorbed by the source, absorbed by the working substance. That absorbed heat energy is denoted with the Q1 amount of heat energy is absorbed. Due to absorption of the heat energy, the expansion will take place in the working substance. That means it will do some work. The work is done by the working substance. That work can be extracted to the surrounding. So that is the work extracted to the surrounding. That work is denoted with the W. Then due to the expansion of the working substance, the working substance is going to the another state. To bring the working substance to its initial condition, the remaining energy will be released to the sink. That energy we will call it as a Q2. Q2 amount of heat energy is sent to the sink. As Q1 amount of heat energy absorbed by the working substance and it is released to the Q2 amount of heat energy to the sink, the work done by the working substance W is equal to Q1 minus Q2. The difference in between them is equal to Q1 minus Q2. As the Q2 amount of remaining heat energy is sent to the sink, then the working substance again it will come to its initial condition. It is a cyclic process because of every time, for every cycle, the working substance, that initial condition is the working substance, condition is there. It will contact with the source, it will absorb some amount of heat energy. Due to the absorption, it will expand. Due to the expansion, some of the heat energy it will lost. So the remaining heat energy will release to the sink due to the contact of the working substance to the sink. Again the working substance will come to its initial state. It is a continuous cyclic process. For each and every time it will drag some amount of heat energy, it will do some work, again it will release to the sink. This is the working process of the heat engine. Now the working substance, the heat engine efficiency will represented with the thermal efficiency parameter. So the efficiency of the heat engine is denoted with the thermal efficiency of heat engine. It will denoted with the thermal efficiency of the heat engine. So how can I define means how the heat engine is performing, how much amount of heat is converted to the work to a work. It will denoted with the thermal efficiency. The thermal efficiency mathematical formula will denoted with the eta is equal to work done by a heat engine in a cycle divided by amount of heat absorbed, amount of heat is taken to the heat engine, that is equal to heat input, that is the heat absorbed by the amount of heat absorbed by the heat engine. So working substance, we will call it as the amount of heat taken by the working substance. So as in the previous diagram, see the work done by the heat engine is equal to Q2 minus Q1 in this cycle. The amount of input taken by the heat engine is equal to Q1 amount of heat is taken by the heat engine, Q1 amount of heat is taken. then the thermal efficiency of the thermal efficiency of the heat engine is equal to work done W divided by Q1. Then W is equal to Q1 minus Q2 divided by Q1. We will having then neta is equal to, by taking the LC to each and individual part, that is equal to Q1 by Q1 is equal to Q2 by Q2, Q2 by Q1, that is equal to 1 minus Q2 by Q1. The same formula can be written as Q2 by Q1 is equal to T2 by T1. This is the formula we are having. Then 1 minus T2 by T1. This is the formula for the neta. So neta formula is equal to, this formula is there. These are the formula for the thermal efficiency of the working substance, efficiency of the heat engine. Now, as in the cyclic process, what we will having means and in the cyclic process, so if a heat engine is working, by taking the how much amount of heat energy is taken by the heat engine, the total amount of heat is converted to a work. Then that heat engine is called it as the perfect heat engine. So we will call it as a perfect heat engine. We are taking perfect heat engine. So perfect heat engine means the amount of heat which is absorbed by a source is identically the same amount of work is converted by the heat engine. So that means that the work done by the heat engine is equal to amount of heat absorbed by the source, so that is equal to Q1. Then the coefficient of the thermal efficiency of the heat engine is equal to 1 minus otherwise we will call it as the W by Q1, we will call it as, then W is equal to Q1 by Q1, that is equal to 1. This is equal to neta value is equal to, so this is the efficiency of the heat engine is equal, neta is equal to 1. So it is a perfect heat engine, but in practical the heat engine may not be possible to convert the how much amount of heat is taken, that same amount of work cannot be performed. It is named as the second law of thermodynamics. We will discuss later. So in practical, so neta is always less than 1 in practical neta. That means no heat engine may not be possible to convert the how much amount of heat is taken from the source, that total amount of heat may not be converted into the work. That is called it as the second law of thermodynamics. We will discuss later. This is about the thermal efficiency of the heat engine and also the working process of the heat engine. I hope you understand this lecture. If you are feeling that these lectures are useful for your academic, I am requesting you please subscribe our channel for the more videos. If you have any doubts regarding these lectures and also any content, so you can ask me in our comment section. I will try to explain. Thank you.